Alrighty, so it's a few minutes after, so we'll go ahead and get started. So welcome in to our workshop today. Oops, of course, this is being brought to you by InfoTech. And if you haven't already, please go ahead and join our Discord. This is the link. And this is our Containerization with Docker workshop. So for starters, we start with our problem statement. Hold on one moment. Okay, sorry about that. So we start with our problem statement. So have you ever developed an application or designed a project, and your code along with all of the possible dependencies you might need? So your libraries, web servers, databases, etc. All of that works perfectly fine on your computer. But then you go over to send this project to your professor, your friend, another developer, and when you send it, it fails to work with the same optimization that it did on your computer, or worse yet, it doesn't even open. So this is a common problem that many have run into, and Docker strives to minimize this. So what is Docker? So Docker is a tool that allows developers, system admins, etc., to easily deploy their applications in a sandbox, otherwise known as containers, to run on the host operating system. So in short, Docker isolates your application to make it independent of the current system that it's running on. So the various dependencies that I spoke about a moment ago, those will all be containerized along with your app in order to execute it like a standardized unit. So usually the way that people go about with running their apps is on virtual machines, but containers, you're able to run this at a fraction of the computing power. So we'll expand on the benefits of Docker. So first, it's portable and it's really lightweight. And Docker also has a platform called Docker Hub. It's really similar to GitHub and really useful. It's lightweight, it's fast, it's flexible because it's compatible with almost any programming language, and it's collaborative. Like I said, it's got a Docker Hub, which is similar to GitHub. So you can share it across with other people and pull and push just as you would in GitHub. So here's a visual kind of the difference between a VM and a container. So over here with our VM, the main difference is the hypervisor. So there's the hypervisor hosts the virtual machine, and how it runs is there's lots of little virtual boxes that now have to be managed for each application. So this takes a lot of time to boot up, and it takes up a lot of resources. However, with our containers, this allows for isolated processes and it gets rid of this entire hypervisor. So because of that, it looks and it behaves like a VM, but with a fraction of the computing power that a hypervisor would require, because only a single virtual box has to be managed now instead of all of these individual ones. So we'll get into a little bit of the terminology that we're going to use today. So the first is images. So an image is essentially the blueprint of the application from which forms the basis of our containers. And it's made up of layers. So when we create our container today, we'll kind of show what those layers look like. And then we have our containers. So a container is an environment with all the necessary installations done for the app that's running in said container. Each container has a running application, and each container itself runs on top of the Docker engine, just like we saw in the diagram a few slides ago. And just like Docker's logo, you can kind of think of it like a logical packing system. So we have all these little containers in our shipping yard, nice and neatly packed away. And then again, Docker Hub, just wanted to actually show you all what it visually looks like. So this is Docker Hub. As you can see, here you can have your own repositories, like I said, and here you can explore all the official images that you might need for your application. So we see Oracle, MySQL, Ubuntu, that's what we're going to be using today, etc. So if you ever have the time, I highly recommend to go ahead and look around here on Docker Hub because it's really useful. Okay. Alrighty, so now we'll move into actually setting up our computer. So as I said before, prior to the workshop, I think you were required to download Python and Docker. So if you've done that, I want to make sure that it's running perfectly fine on your computer. So we're just going to run this command in our terminal mode to make sure that everything's running just fine. So let's go ahead and do that. So we open up your terminal mode, your command prompt, and whatever machine that you're using. And is everyone able to see this? Actually, it'd probably be good if I could see the chat one moment. Okay, good. Alrighty, so we're going to do Docker run hello dash world. Okay, and so you should get this message, hello from Docker. This message shows that your installation appears to be working correctly. So great, first step done. 1 second, okay. Alrighty, so now what we're going to do today is containerize our own Flask application. So these are some common commands that you usually use with Docker. Because it's such a basic workshop today, we are not going to use a lot of these. However, if you ever like to refer back to them in the future, this is being recorded. So if you want to ever come back to this PowerPoint and take a look at them, you can. And this is basically a rundown of what we're going to be doing today, kind of in a web map form. So of course, we're going to create a very basic Flask application, just a hello world, nice and simple for demonstration purposes. So that'll be first. And then that's when we're going to come over here and start to create our Docker image. So as I said earlier, they're kind of built upon layers, and this is the process that we're going to go through. So installing telling the image that we'd like to install Python, install pip3. Then we're going to copy the source code from what we create in our Flask application to this image. We're going to expose the port that it'll reside on, and then we're going to make the container executable, and then boom, we'll have a new Docker image. So let's go ahead and get started with that now. Okay, so we're going to head back to our terminal mode and create our Flask application. Also, if you do not have Flask installed, I think you can do a pip install Flask. And that should go ahead and get everything that you need. It's already satisfied, obviously, for me. But okay, so let's get started by creating a folder for our Flask application. So I'm going to put this folder on my desktop. So change directory to desktop. And now that we're there, we're going to make directory, and we're going to call it Flask. Great. Okay, and so then we're going to change the directory to Flask as well to go inside that folder. Okay, and so using any text editor that you prefer, we're going to go ahead and create our Flask application now. So I'm going to be using Atom today. 1 second, just so I can see. Okay, so we're going to go ahead and create a new file. And we're going to go and save that into the Flask folder that we just created. So desktop and Flask. And today we're just going to call it app. So app.py and save. Okay, so now we'll get started. So for starters, the first line is going to be from Flask import. Okay. Now we're going to create an instance of our Flask web application. So app equals Flask underscore underscore name underscore underscore. Okay. And now we're gonna create the part that actually makes our app run. So if underscore underscore name, oops, underscore underscore equals equals underscore underscore main underscore underscore colon, then app dot run debug equals true, comma host zero, oh, sorry, quotes 0.0.0.0. Okay, so basically these lines of code just make our app executable. And as I said, we're going to make it super duper simple. It's just going to be a hello world application. So we do that by defining the home page. So making a function for our home page. So it's going to be at app.route quotes backslash, okay, define home parentheses colon return hello world. Alrighty, and that's all. Super simple. Command S to save it, and to show that, you know, our app is up and running and doing just fine, we'll go back over to our terminal mode and type in Flask underscore app equals app.py, which is the name of the application we just made, Flask run. One moment. I did something wrong over here. Ah, I see. I'm sorry. It's not a colon. It's an equal sign. Okay, so let's go ahead and save that one more time, and hopefully this runs now. Okay, great. So we can ignore this warning sign. What we want to focus on here is this. So we'll go ahead and copy that, Command C, and just open up a web browser and go ahead and paste that URL, and boom, hello world. So our Flask application is running, and now we can turn it into a container. So that'll be the next thing that we do. Okay, so back to your text editor of choice, we're going to create a requirements.txt file. So same process, file, new file. We're gonna go ahead and save it in that same folder. So desktop, Flask, and we're going to call this requirements.txt. See. So essentially, this is telling your image that we've made an application using a Flask framework, and we're telling it the version of Flask that we're going to need as well. So this is important for your image in order for these layers to get created. So it's super simple. We'll do Flask equals equals 0.10.1. So that's the version of Flask we're using. Now for, like I said, this is a simple application, but let's say that your application had a lot more requirements, a lot more dependencies. For instance, instead of Flask, maybe you were using Django. That's where you would list all of those as well. Okay, so we're gonna do Command save. Once again, I'll close this. We don't need that right now. Okay, and so now we have one more file to create in order to finally create our Docker image. This is probably the most crucial part of creating your Docker image. So once again, new file, save as, in the same location that we've been saving everything else. So Flask, and this is going to be called Docker file. Docker file. Okay, save. So like I said, this is probably the most important component. Without this, we can't build our image. And essentially, it's the instructions or the layers, as we've called it earlier, to run your application. Okay, so we start with from. So this from Ubuntu 16.04. So this initializes a new build, and it basically defines the base of the image. So today we're using Ubuntu for the base of our image. Okay, and so next we'll write out these lines. So run apt-get update -y double ampersand and backslash. The double ampersand just allows two commands to be ran on like one line. Okay, and then we'll enter in tab apt-get install -y python-pip python-dev. So with these lines, we've essentially gotten the downloads needed for this application. So of course, in this case, it's Python because in our application, we use the language of Python to create it. Okay, and so the next command that we're going to use is copy. So right now we're going to copy what's in our requirements folder to this new directory, or to a essentially to our new directory. So copy /requirements .txt /app/requirements .txt. So as I said, we're creating a new directory and we're calling it app because that's the name of our application, of course. And so then we're going to create that directory. So working directory /app. Okay, so now we've set the working directory where we'd like all this information to reside. And so this next command that we're going to do is run pip install -r requirements .txt. Okay, so with this, we're basically, now that we've copied what's over in the requirements.txt, now we're actually like running the installations and things required in this requirements.txt. Okay, almost done. We'll do copy /app. So right now we've copied all the source code from what we just created in our app. So now that's also in our image. So do you see how we're kind of slowly creating these layers? And now we're coming to the end. Now we'll do entry point, brackets, Python. And what this does is makes, it configures the container to run as an executable, sorry. And so finally, we have CMD. And in here, we'll do app.py. And then this is what's going to allow us to execute our app. And boom, we've created our Docker file, which is what we'll need to actually run this image and create it. Okay, so we're going to do Command S, go ahead and save that as well. And in our terminal mode is where we're actually just going to build and run this image, okay? So to make sure that you have everything you need, you can go ahead and look at your Flask folder, if I can find it. There it is. Okay, so you see we've got our app, we've got our Docker file, and our requirements.txt, so that's all that we'll need. Okay, so we'll go back over to our terminal mode and we can do Control-C to exit that. I'm going to go ahead and clear the screen so we don't have to look at everything that we did previously and start fresh. Okay, so now we're going to build it. So it's Docker build -t, and we're going to name it Flask tutorial /latest. Okay, So we've built it, doesn't do much, we've just built the image. Now we're going to run the container. So we'll do Docker run -d -p, and the port that we're going to use is 5000 colon 5000 Flask tutorial, which is what we've named it. And that's it. We've created a Docker image and the container. And to show that we've done that with our Docker desktop installed, you can go ahead and open it and go to your dashboard. And see that it's running right here. You see Flask tutorial. So you can go ahead and click on it and look at this little URL here. Command C, and then we'll go back in our browser and boom, it's the, well, 1 second. Okay, there it is. This is the app that we created, and now it's within our own little Docker container. And so, like I said, if this was an app that was more complicated, etc., it would have been able to run that much faster without any complications that you normally run into when you end up sending your project to someone else. And you can also view your containers in terminal mode as well by running this command. So Docker ps, and that lists your containers as well. So here we have Flask tutorial. And so yeah, so we've successfully created our own image in our own container. And once again, I encourage you to explore Docker Hub for yourself and check out, the world of images on there. And, I hope this was helpful for you. And in the future, when you'd like to deploy your application, you can do it in this super efficient way. So, if there's any questions, feel free to send them in the chat. And I believe that this is recorded. So if you'd like to revisit this and look at it at a later date, you're more than welcome to. And yeah, and so InfoTech has a lot of other events coming up in the next few weeks, so be on the lookout for those. And I thank you all for coming. I hope you have a great weekend.